Hello friends, today we are going to discuss fluid mechanics and that too for JEE Advanced. I hope some of the question that we are going to study here will help you a lot. So, I will like to start some question which have some concepts from different fields including Reynolds number, uh, theory of continuity and different parts of Bernoulli's equation as well. So, let us start. So, let us see our first question. This is regarding free fall of a body which is supposed to experience fluid resistance, that is air resistance, and that is why it is going to attain some, what do you call that, velocity, terminal velocity. So, let us read it. Which of the following option correctly describes the variation of the speed v and acceleration a of a point mass falling vertically in a viscous medium that applies a force F equals to minus kV. So, obviously this force minus kV is the resistance, is the air resistance where K is constant on the body. So, one way is approaching directly using equations, like the net force acting on that body. Suppose that force is equal to the gravitational force and the resistance, that is F equals to minus kV, that is also added to it. So, simply we would say kV. If we need to find out the net acceleration on the body, we would simply divide both sides by m, that is the mass of the body. So, let us say we do it acceleration equals to Fg by m, whatever is the gravitational force on the body, it will give us the acceleration due to gravity for that point. And we know if the height or the altitude is not differing that much, you are most likely to get a almost constant value of g, acceleration due to gravity. Now we will be having k by m times v. So, what is this k by m? This is some constant because k is here a constant, right, and v is here the velocity of our point object or point mass. Now, if you go back to the definition of acceleration, it is rate of change of velocity. We can simply replace a by dv by dt. You see differentiation and integration is getting involved here. So, if you consider this thing here, we are getting derivation differentiation of v respect of t is equal to g minus k by m of k by m times v. If we write it in some different way, we would be getting dt equals to, that is what we need to find time taken, or say the relation between time and velocity. So, what we can do, we can relate these two things with whatever assets, whatever resources we are available with. So, we can relate it by relating one part with the relevant information and another with relevant. So, you see in this function, if we take this thing as a function, we see that we have various constants here. This thing is a constant, this thing is a constant, but v is a variable, and v can be related to dv here, which is nothing but a derivation thing, sorry, differentiation thing, not derivation. So, if we take v that side, we would be getting dt taken upside and dV divided by this whole expression. So, oh, we are getting dV divided by G minus K by M by times V. So, you see this is a formula of a type, let us say dx by 1 minus kx, something of that sort. And if we integrate this whole thing, we would be getting let us say integrate both sides from 0 to the final value. So, let us say the time is 0 to t. So, we are getting the function v with respect to time t. So, our time t here that we are getting t would be equal to ln of, sorry, so this is our equation. Our equation looks like something like this. Here we are getting v in terms of t, or simply you can see t in terms of v. We can relate this thing in a different way, like if we take out this whole thing. So, let us name this whole thing k by m as say delta. Okay. So, minus, or no, delta could be confusing, let us name it beta. So, minus beta t equals ln of this thing here total. So, ln of g minus beta v. In fact, I should have taken a bit of blank paper to work on it. So, if you extend this thing here using E, means and taking anti-log on both sides, what would be getting g minus beta v, sorry, beta v g minus beta v is equal to e to the power minus beta t So, now our equation is something like minus x is equal to e to the power minus x. So, our graph of this thing would look like something that grows with time. So, it would be something of this sort. We are calculating V, right? V is growing, but after some time it is getting stagnated, because e to the power minus beta t it grows, but it gets stagnated. If you consider only this part, it goes something like this, but we have here minus sign, right? Means if you take v only, we are getting minus it would be something if we consider this. V is equal to G minus e to the power minus beta t the whole divide. What is happening here? The whole divided by minus beta, sorry, beta. So, in that case, so in that case, what is happening here? Come on. Yeah, yeah, it's beta. So, you are getting, this is a reverse form of e to the power x, e to the power minus x, means e to the power x would go something like this graph here, but we have something like this because it is negative here. So, that is our velocity graph. We can simply rule out this one here because velocity is growing here upwards, and here velocity has grown, but it has now stagnated. This is quite good, but we will find out if A is that kind of linear. So, here is also V is ruled out. Here we cannot rule out V, here we cannot rule out V. Now consider A. Is A constant or is A decreasing or increasing with a constant pace? No, A is not constant because obviously the acceleration has some component associated with it. So, and we know V is growing, so definitely A has to, the speed at which, means the rate at which A will increase, acceleration will increase, has to go down. So, acceleration is decreasing obviously here, so has to go down. So, that means its graph should be something like this, means obviously it is decreasing, but its rate of change is also decreasing. So, that is why a slope, a downward slope, while slope is also decreasing. So, this is how our acceleration is. So, cannot be a general linear graph. So, let us rule this out as well. So, only answer D. D is our correct answer. So, do you find, okay, do you find this workable to you? I hope you get it. So, we will move on to our next question. Okay, so this question is related with theory of continuity. Let us read it together. Consider a water jar of radius r that has water filled up to height h and is kept at a stand of height h. So, the stand of height is small h. You can see that in the figure, right? Through a hole of radius r, where r is much smaller than capital R at its bottom, the water leaks out and the stream of water coming down towards the ground has a shape like a funnel as shown in the figure. If the radius of the cross section of water stream when it hits the ground is x, then, so it tells us that the radius is x. That means you can see the diameter has been shown as 2x, so do not get confused. And radius of this whole container is r. So, we have to find out the relation between x, r, h and smaller h, or say smaller h and capital H. So, first let us find out what is r, or say what is the velocity of efflux. So, you know, if the velocity at which water oozes out through a leak, it is given by 2gh, where h is the height of the container, and we know that here the height of the container is capital H. So, that would be 2g capital H. Now, if we consider the distance from here to here, the difference in conditions. So, here we can see that there is some circular hole here and there is some circular section here through which water is passing through. Whatever we are doing the change in speed and relating with that with the change in the cross section of the fluid flow. So, we know the concept of continuity continuity of flow. So, if some volume is passing through this part, the same volume would be getting out of that the lower part. So, A1 V1, this let us say this is smaller v because that confuses with the volume. So, A1 V1 is equal to A2 V2. Now, what is A and what is V? A is the area, cross section area through which water is coming out, and this here A2 is the cross section area through which water is striking the ground. So, and we are considering this a continuous flow. So, A1 V1 equals to A2 V2. Now, consider the velocity v is 2gh here. यहाँ से यहाँ तक velocity में क्या change आएगा? We know that the distance is h, right? So, we know हम simply mgh or don't go to mgh. We know that for a distance covered, while the acceleration is constant, there is a change in velocity, and we can work that out using v square minus u square equals to 2as. S being the distance, so simply rule that out as, and we know final v, we do not know this value. So, v square, u square, we know initial velocity is under square root 2g capital H. So, u square would be 2gh. Now, 2as, acceleration is g, s is this height h, smaller h, 2g smaller h. Now, take it this thing here, we are getting v square equals to 2g capital H plus smaller h. So, 2g times capital H plus smaller h. Now, if you find that square root of both sides, we would be getting v equals square root of 2g h plus h, capital H plus small h. Now, we have v here for this point, we have v here for this point. We know the area A here, that would be pi r square. This you are seeing this as 2r, this is because the diameter here is 2r. So, pi r square times square root 2gh, let us write here pi r square times square root 2 gh, here we have capital H, is equal to what? Why is it equal to? What are we doing? A1 V1, this part is A1, this part is V1, is equal to A2 times V2. What is A2 here? Where the radius is x, it says where it hits the ground is x. So, pi x square times 2g h plus h. Okay. So, we can now easily rule it, solve it. For doing that, let us rule out pi getting cancelled with pi. If you square both sides, that would be very easy. So, let us square both sides. What are we getting? R to the power 4 times 2gh, 2g capital H is equal to x to the power 4. Okay. Now, let what we had to find? We had to find x. All the our options are as x. So, let us find out x in terms of r. X is equal to this quantity here divided by the whole this quantity here. So, and we have x to the power 4. So, we will get fourth root of this whole quantity that we are going to write on the right side. So, 2g h plus h divided by 2g small h, and that would be, sorry, did I do something right? Okay, sorry, x would be equal to this quantity divided by this quantity here. So, not these h, this 2g capital H divided by 2g times capital H plus small h. Now, we can cancel out 2g and 2g, both are in the same denominator, and we have r to the power 4 as well, and x to the power 4 as well. So, if we are cancelling these things here, what we are left with? X to the power 4 equals to r to the power 4, the whole into capital H divided by capital H plus small h. Now, taking fourth root on both sides, what we get? Fourth root on the left we get x, on the right we are getting r times h divided by h plus small h, the fourth root of this thing. So, we can simply write to the power 1 by 4, and do we have an option that meets this? X equals to r times h divided by h plus h, all are in the same format, but it has form the exponents are different. The only right exponent we are getting here is 1 by 4 in option C. That is our option. So, I hope everyone is clear on that. Okay, I'm getting comments like it's quite difficult and not able to understand. So, that was my expectation. The topic is somehow difficult, and there are complicated equations coming out. From next time I will try to have a bigger blank sheet where I could explain it better, but for now please bear with it. We'll move on to our next question. Okay, so here it has something very much conceptual. Let's try and read it together. If two glass plates have water between them and are separated by a very small distance, it is very difficult to pull them apart. It is because the water in between forms cylindrical surface on the each side that gives rise to lower pressure on the water in comparison to the atmosphere. If the radius of the cylindrical surface is r and the surface tension on water is T, then the pressure in water between the plates is lower by. So, you see this is the surface of the glass, one sheet, another sheet here, and there is some water content uh, here and here, and then what we are getting, if we are trying to pull out these two sheets, it forms a cylindrical surface. So it is not exactly cylindrical, it is not vertical, but somehow it is related to cylinders. If you break it into several layers, they are cylindrical surfaces of water. So what you need to find out, you need to find out the pressure in what in this um, water body between the two plates and the pressure into this as compared to the pressure of the atmosphere. So let us try it together, but before that I would like you to brush up some concept and find out what its answer is. You can go through some basic books and you can find its answer. Meanwhile, I am out of syllabus. So I hope you have tried on it, and you see in this question you can very easily go through the concepts whatever you have studied about excess pressure, about soap, bubble, etc., you can utilize it. So, here you have two surfaces on both sides. You see, we have surfaces here and surfaces here. And this is a very theoretical part. Whenever there is a bubble and it has some bubble or say drop, liquid drop, and it is attaining an area radius r to minimize the surface area, you are getting that what we were considering. Yeah, the excess pressure inside this liquid would be T by R. This is very theoretical and its derivation would take time. So, I am skipping this part. Let us try, and based on our time constraint, I will try to skip some of the question and let us see what we can discuss more. This is a question I would like you to see and you can solve it by yourself. A beaker contains a fluid of density rho kilogram per meter cube, specific heat S joule per kilogram per degree C, and viscosity I would say. So, let us say the viscosity is eta. It is not written properly here, it should be something like this. So, viscosity is eta. The beaker is filled up to height h. To estimate the rate of heat transfer per unit area, that is total heat divided by area. By convection, when beaker is put to the hot plate, a student proposes that it should depend on eta and this quantity S delta theta by h. Delta theta is the change in temperature, S being the specific heat, and 1 by rho g. Rho is the density of the liquid and g is acceleration due to gravity. When delta theta has been explained in the question, is the difference in the temperature between the bottom and the top of the fluid. In that situation, the correct option of QA is. So, I am not going to solve it here because it will take a lot of time and that will consume our basically designed designated time here. So, what we can do, you can go through dimensional analysis and see if all these variables that the student had suggested is satisfying our situation or not. So, to estimate the rate of heat transfer, so what we are going to do, we are going to means you are going to check the dimension of this quantity here and relate how they would be related to. So, let us say I named it A being eta, this part as B and this part as C, and we had this Q dash by A. So, dimension of this would be somehow equal to A to the power x, B to the power y and C to the power z. If you simply analyze all the 3 units, you will get the 3 equations of x, y, z. So, you will be getting 3 equations, 3 unknown. You can solve that and find out the values of x, y and z, and by doing that you will simply come out to know which is the right answer, because you see the first one is giving n eta to the power n, this to the power eta to the power 1, this quantity to the power 1 and this quantity to the power 0, that is why it is not included. So if you are solving and getting x equals to 1, y equals to 1, z equals to 0, then this would be your answer. But if you are getting something else like x, y, z all are equal to 1, then you would be getting this answer. So it's up to you, solve it and find out whichever is the right answer. I will meet you soon, and I hope at that time we can discuss this part if time permits. Okay, that's all for today. We'll meet soon. See you. Bye bye.